Hi everyone, welcome to video lecture number 5. Our video today is about a really important part of an atom, valence electrons. You already know what electrons are, but the word valence is probably a new one to you. An object's valence is its capacity to react with or affect something else. So valence electrons have something to do with chemical reactions. Go ahead and pause the video to write down the essential questions. I'm going to use the words reactivity and reactive quite a bit in this lesson. So let's get a handle on what that means. Reactivity is simply something's ability to chemically react with something else. A chemical reaction takes place when atoms of substances rearrange themselves to form new substances. Reactivity is not a physical property that you can observe with your 5 senses. I can describe the physical properties of the substances that make up this match. Things like color, how it smells, hardness. But the chemical properties of the match, like flammability, can only be observed during a chemical reaction that forms new substances with different physical properties. An object's reactivity is a chemical property and can only be observed during a chemical reaction. Now, how reactive a substance is depends on the atoms that it's made out of, and how reactive an atom is depends on how many valence electrons it has. So what is a valence electron? It's simple. Valence electrons are the electrons located in the outermost energy level of an atom. They are the ones that are furthest away from the nucleus of the atom. Look at the atom on the slide. The nucleus is modeled differently because instead of all of the protons and neutrons being drawn out, they're just written down next to the symbol for protons, a lowercase p with a plus sign, and neutrons, a lowercase n with a 0. By the way, the written symbol for an electron is a lowercase e with a minus sign. You may have seen me use these symbols already in class. They save a lot of time when you're modeling atoms, especially if you're trying to draw an atom like sodium with 23 subatomic particles in the nucleus. Anyway, back to this atom. I know it's an oxygen atom because it has 8 protons, and oxygen has an atomic number of 8. You can fact check me on your periodic table. Oxygen's valence electrons are these ones in the second energy level. 1, 2, 3, 4, 5, 6 valence electrons. These 6 electrons are the only thing responsible for oxygen's chemical reactivity. In other words, they're the only electrons that do anything in chemical reactions. These 2 first electrons, the ones in the first energy level, and the protons and neutrons in the nucleus, they don't have anything to do with reactivity. This oxygen atom will pair up with other atoms in a chemical reaction by gaining, sharing, or losing its valence electrons. That's what a chemical reaction is. When I burned that match in the last slide, the atoms in the match head were exchanging and sharing valence electrons with oxygen atoms like this one to form water vapor and carbon dioxide gas. That's pretty cool. I said before that atoms are kind of like Lego blocks. Do you remember that? Well, that analogy works well with the idea of valence electrons. You can think of valence electrons, the electrons in the outermost energy level of an atom, as kind of like the bumps on Legos, the ones that let you snap blocks together. The bumps are a very small part of the block, but without them you couldn't build anything that would stick together. Valence electrons are like that. They are a small part of the atom, but they are what cause atoms to stick together. Because of valence electrons, atoms can create chemical bonds and build huge molecules. Let's take a closer look at how valence electrons work. So why do atoms gain, lose, or share valence electrons in a chemical reaction? Because of the rule of 8, or octet rule. You see, all of the atoms on the periodic table are electrically neutral. They have a net charge of 0. But they aren't chemically stable. An atom is only chemically stable if it has a full outer shell of valence electrons. You can think of an atom with a full valence shell as a happy atom because it's become stable. The octet rule states that atoms will give, take, or share valence electrons until their outer layer is completely full, like this neon atom. Notice that I just wrote the chemical symbol for neon in the nucleus. I didn't bother with the protons and neutrons because we're talking about reactivity, and the only thing that matters with reactivity is valence electrons. Neon is an element that won't react with other elements. It doesn't combine with other atoms because it already has 8 valence electrons. It's already a happy atom. But think back to the oxygen atom we saw on the last slide. It had 6 valence electrons in its outer shell. That leaves room for 2 more electrons. It's not an outer layer that's full. It's incomplete. It's kind of like there are 8 parking spaces in the outermost energy level, but only 6 of them have cars parked in them. The octet rule says that oxygen will fill up those last 2 parking spots. It will take or share valence electrons from other atoms until its outer shell is full, just like neon. Oxygen wants to be happy too, and it has to form chemical bonds with other atoms to get there. One side note, some atoms only have 1 energy level, like hydrogen, and it's full of valence electrons when it has 2, because the first energy level can only hold 2 electrons. It only has 2 parking spaces, so to speak. Okay, let's look at 2 examples. Before we take a look at example number 1, pause the video and try to answer the 4 questions on the slide by yourself. Then we'll go over them together. Okay, the first question is pretty simple. Valence electrons are the electrons found in the outermost energy level. So even though sodium has 11 electrons total, only this one, the one in the 3rd energy level, is a valence electron. So sodium has 1 valence electron. To answer question number 2, you have to think way back to the 6th grade. Sodium is found on the left-hand side of the periodic table, which, believe it or not, makes it a metal. Most of us think of salt, but salt's a compound. Pure sodium is a metal. If you didn't know the answer to this one, don't sweat it. We'll review metals, nonmetals, and metalloids in our next unit on the periodic table. Now, the 3rd question is an interesting one. In the last slide, we learned about the octet rule, or the rule of 8, that every atom wants to be stable by obtaining a full valence shell of 8 electrons. Atoms can get that full shell by giving electrons away or by getting electrons. Do you think it's easier for sodium, this atom, to get rid of its 1 valence electron or to gain 7 more from other atoms to get a full shell of 8 valence electrons? It's way easier for sodium to give away that 1 valence electron than it is to gain 7. So it will get rid of this valence electron by giving it to another atom in a chemical reaction, making it stable. When it does, look at the electron cloud. Now it only has 2 energy levels because it gave 1 electron away, and the outside shell, the valence shell, is completely full with 8 valence electrons. Now the last question is one about net charge. We could look sodium up on the periodic table to figure this out, but we really can do it in our heads. This sodium atom just lost 1 electron, right? It did not lose any of its protons. It lost one of its negative charges with that electron, but none of its positive charges. Because the sodium atom now has 1 fewer electron than protons, it must have a net charge of +1. It has 1 more positive charge than negative charges. So it becomes a positive ion with a charge of +1. Okay, let's move on to example number 2. Go ahead and pause the video again and try to answer the questions on your own, just in your head, before we go over them together. Okay, first question. This atom of chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons in its outermost energy level. chlorine is on the right-hand side of the periodic table. So that makes it a nonmetal with 7 valence electrons. And chlorine is the opposite of sodium. For question number 3, it needs 1 valence electron to have a full outer shell of 8 electrons. Instead of trying to get rid of 7 valence electrons, it's much easier for an atom like chlorine to gain 1 electron in a chemical reaction. Maybe that 1 valence electron could be from the sodium atom we saw on the last slide. If it gains 1 electron, then that means it has 1 more electron than it does protons, 1 more negative charge than it has positive charges. So this atom, question number 4, becomes a negative ion with a charge of -1. When atoms become ions, when their net charge becomes positive or negative, cool things begin to happen. Remember that positive and negative charges attract each other? In the next video, we'll see how positive ions and negative ions chemically bond to create compounds. We'll also learn how some atoms can share electrons to form chemical bonds. See you then.